Hello. Today, we are going to talk about biodiesel. We've prepared a total of 5 topics. Are you all ready? Let's get started. This part is the definition and properties of biodiesel. What is biodiesel? Biodiesel is mainly made from vegetable oil, such as soybeans and citrate oil, and animal fats through esterization process. This is an eco-friendly fuel that burns 40 to 60% less air pollutants than conventional diesel fuel. 1 kilogram of biodiesel has a 3.2 kilogram carbon dioxide reduction compared to the same amount of petroleum-based diesel. This is biodiesel production process using waste oil. Next is the production process. Blends of biodiesel and conventional hydrocarbon-based diesel are products most commonly distributed for use in the retail diesel fuel marketplace. Much of the world uses a system known as the B factor to state the amount of biodiesel in any fuel mix. Biodiesel has promising lubricating properties and cetane ratings compared to low-sulfur diesel fuels. Fuels with higher lubricity may increase the usable life of high-pressure fuel injection equipment that relies on the fuel for its lubrication. The calorific value of biodiesel is about 37.27 megajoules per kilogram. This is 9% lower than regular number 2 petrodiesel. Variations in biodiesel energy density is more dependent on the feedstock used than the production process. The color of biodiesel ranges from golden to dark brown, depending on the production method. The flash point of biodiesel exceeds 130 degrees Celsius, significantly higher than that of petroleum diesel, which may be as low as 52 degrees Celsius. Biodiesel contains virtually no sulfur. The power output of biodiesel depends on its blend, quality, and load conditions under which the fuel is burnt. The thermal efficiency, for example, of B100 as compared to B20 will vary due to the differing energy content of the various blends. Emissions are inherent to the combustion of diesel fuels that are regulated by the U.S. Environmental Protection Agency. As these emissions are a byproduct of the combustion process. In order to ensure EPA compliance, a fuel system must be capable of controlling the combustion of fuels as well as the mitigation of emissions. Many studies about emission have been conducted. Biodiesel is available in many different materials such as plastic, metal, and rubber. This part is production of biodiesel. Renewable energy accounts for only a small portion of the world's energy sources. Of the 131.5 billion tons of the world's first energy consumption, new and renewable energy accounts for only 2.8%, or 3.6 billion tons. Biofuels, which account for more than 50% of renewable energy, also account for significantly less energy sources. From 2001 to 2015, biofuels increased by 715%, while crude oil production increased by 22.4%, natural gas 46.6%, and coal by 66.4%. Biofuel production in 2015 accounted for 41.4% of the world's total production of 3,098 million tons. Brazil remains second with 17.64 million tons in 2015, despite the slowest pace of growth. Production was 31.1 billion liters annually between 2013 and 2015, and is expected to increase 33% to 41.4 billion liters by 2025. Unlike ethanol, biodiesel is the largest producer and consumer of the EU. As of 2014, the percentage of production and consumption of the EU will be 38% and 44% respectively, and both production and consumption will be 28% by 2025. The United States is rapidly pursuing the EU to meet the mixed martial arts ratio. About 60% of the materials used in Korea are imported from palm oil, while the remaining 40% are imported from Korea based on waste oil. The consumption of waste food from the start of biodiesel is maintained at a constant rate of 180,000 tons to 190,000 tons per year after 2013. This is 85% of the total amount of spent cooking oil. Animal fat use has steadily increased since 2013, 13,000 tonnes per year, and 270,000 tonnes per year has been used in 2015. Oil is the only energy crop that can be grown locally. It consumes 82 liters of fuel per hectare to produce a single crop. But the rape crops average 1,029 liters per hectare. In this case, the ratio of input to output is approximately 1 verve 12.5. The overall efficiency of the chain is now about 1. Statistics alone do not determine whether it is economically feasible. Additional factors should be considered. The United States, Canada, and the EU have predicted that 30 to 70% of existing agricultural land will be needed to replace 10% of transport fuel with biofuels. It also predicted that the price of sugar will increase by more than 60%, and the price of vegetable oil will rise by 20% due to the large impact on the agricultural market. Because energy consumption is proportional to economic output, big economies face difficulties. Therefore, small economies and large arable countries are appropriate. In tropical areas such as Malaysia and Indonesia, palm oil producing plants are rapidly growing to supply biodiesel demand in Europe and other markets. Scientists have shown that removing rainforests for palm tree farms poses a threat to the pristine tropical rainforest and biodiversity, and is ecologically unhealthy. This part is status of utilization and research. Recently, the use of biofuels has been expanded to cope with high oil prices and climate change. Currently, biofuels are mostly used for transportation, and power generation uses have been gradually expanded. The first example is vehicle. Starting in 2004, the city of Halifax, Nova Scotia in Canada updated its bus system to allow the fleet of city buses to run entirely on a fish oil-based biodiesel. In 2005, Chrysler released the Jeep Liberty CRD diesels from the factory into the European market with B5. The Volkswagen Group has released a statement indicating that several of its vehicles are compatible with B5 and B100 made from rapeseed oil and compatible with the N14214 standard. Mercedes-Benz does not allow diesel fuels containing greater than 5% biodiesel B5 due to concerns about production shortcomings. The 2014 Chevy Cruze Clean Turbo Diesel, direct from the factory, will be rated for up to B20 biodiesel compatibility. In 2007, McDonald's of UK announced it would start producing biodiesel from the waste oil byproduct of its restaurants. This fuel would be used to run its fleet. Next one is railway. British train operating company Virgin Trains claimed to have run the UK's first biodiesel train, which was converted to run on B20. In 2007, the British Royal Train completed its first ever journey run on B100 supplied by Green Fuels Limited, and it is running well. Similarly, a state-owned short-line railroad in eastern Washington ran a test of B25 in 2008. The biodiesel is made in part from canola. In 2007, the Mountain, Washington Cog Railway decided to use biodiesel on all steam locomotive fleet. Also in 2007, Disneyland began running the park trains on B98. The program was discontinued in 2008 due to storage issues. But in January 2009, it was announced that the park would then be running all trains on biodiesel manufactured from its own used cooking oils. This is a change from running the trains on soy-based biodiesel. On the 8th of July 2014, Indian Railways announced that B5 will be used in Indian Railways diesel engines. Biodiesel can be used as a fuel of aircraft. There is a Czech jet aircraft completely powered on biodiesel. However, other recent jet flights have been using other types of renewable fuels. In 2011, United Airlines flew the world's first commercial aviation flight on a microbially derived biofuel using Solajet, Solazymes algae. The EcoSky's Boeing 737-800 plane was fueled with 40% Solajet in jet fuel. In 2016, the Dutch flag carrier KLM contracted Altair Fuels to supply all flights departing Los Angeles International Airport with biofuel. The last one is biodiesel in generators. In 2001, UC Riverside installed a 6-megawatt backup power system that is entirely fueled by biodiesel. Its generators allow companies to avoid damaging blackouts of critical operations at the expense of high pollution and emission rates. By using B100, these generators were able to eliminate the byproducts that result in smog, ozone, and sulfur emissions. In 2007, Biofuels Power began operating a 5-megawatt power plant that uses only biodiesel as fuel, made from vegetable oil, or animal fat. It plans to build a 10-megawatt power plant in the future. 10 megawatts of electricity is equivalent to the amount that can supply about 3,000 homes. Currently, biodiesel is commonly used in transportation. But biodiesel made from animal fats is more suitable for power generation facilities. However, the diesel can't function properly because of the cold weather, so it has to keep it warm. Because biodiesel uses food as a source, there are some problems. They are instability of supply and demand and food security problems. To solve the problems, there are many research to use used waste oil or non-durable food as a source. Biofuels can be distinguished by materials like this. The first generation is food or edible crops. For example, corn, sugarcane, sugar beet, cassava, soybean, rape, palm oil and so on. The second one is non-food crops. They are cellulose, jatropha and so on. The third one is seaweed, microalgae and so on. Therefore, I would like to address the second and third generations. An article released by Michael Briggs from the UNH Biodiesel Group shows an estimate to replace all car fuels with biodiesel by utilizing algae, containing more than 50% of oil. These algae can be grown in ponds at wastewater treatment plants. ExxonMobil and Sapphire Energy in the US and Britain and Germany are also studying algae biomass. In addition, Korea's Jung thermal power plant has been steadily conducting research, and successfully completed the driving test in 2015 to drive about 400 kilometers from Seoul to Busan. With increasing interest in renewable energy sources, the method of producing liquid bioenergy from plant oil is drawing attention. Milleta pinnata, also known as pongamia, is a bean-fed crop for non-eating vegetable oil production. There are advantages that the trees store carbon and produce fuel oil. It grows on marginal land, not fit for food crops, and does not require nitrate fertilizers. Its yield of oil-producing plant is about 40%. The main advantages of it are a higher recovery and quality of oil than other crops, and no direct competition with food crops. Jatropha is a tree that has toxic seeds. It is considered a representative source of biodiesel. Jatropha is used for prevention and control of soil erosion, natural fencing and deforestation. In addition, they grow well in the climate of most regions easily, and have a high oil recovery rate. The byproduct of the pressed cake is organic waste, which is used to produce fertilizers and biogas. Because it is a toxic plant, it does not affect the grain market, and large-scale cultivation does not cause land to be destroyed. Unlike crops, microorganisms can produce large quantities of fungus in a short period of time in a small space. And biodiesel can be produced reliably through a standardized incubation process that is completely unaffected by the environment. The recent discovery of a variant of the fungus, Gliocladium roseum, points toward the production of so-called mycodiesel from cellulose. This organism was recently discovered in the rainforests of northern Patagonia and has the unique capability of converting cellulose into medium-length hydrocarbons typically found in diesel fuel. Spent coffee grounds, SCG, are disposed of or are used as compost in part. SCG is analyzed to contain between 10 and 15% of oil, and researchers at the University of Nevada in the United States used SCG to produce biodiesel. The method of production is to extract oil and then produce biodiesel through the existing biodiesel production process. Technology is not difficult, and it has been reported that coffee is available to produce hundreds of millions of gallons of biodiesel per year. However, even if all SCGs around the world are used to make fuel, the amount produced will be less than 1% of diesel used in the US every year. Therefore, it will not solve the world's energy problems. This part is global biodiesel policies. Despite the high cost of production, biodiesel has increased its production capacity rapidly, due to its environmental-friendly and renewable energy advantages. As a result, many countries have their own policies for using of biodiesel. Let me explain the policies of the United States, Europe and Korea. In the U.S., the Energy Policy Act defines the use of eco-friendly energy as essential, and recommends the use of biodiesel. And the federal government has set up policies to increase the demand for renewable energy vehicles and use of renewable energy and biodiesel blending fuels. In addition, the oil distributor was given a tax credit of 1 cent per 1%. The supply of biofuel after 2015 will utilize all non-eating materials. 12 states including California are planning to implement low-carbon fuel standard by giving additional points to biodiesel that uses wastewater to reduce greenhouse gas emissions. However, the biodiesel market is not a representative alternative energy market as it is perceived that it is not eco-friendly. Biogas greater than biodiesel in the US anyway, the market is expanding through using blend with other diesel. The European Union is the largest producer of biodiesel. Especially in Germany, the spread of biodiesel is now the world's #1 producer of biodiesel, producing 62% of EU biodiesel. There are several policies in the EU to increase the use of biodiesel. First, biodiesel blend with other diesel. BD5 is available for sale in all European regions. The EU has decided to replace 2% of car fuel with biofuels in 2005, 5.75% in 2010, and 20% in 2020. Therefore, the production and use of biofuels is expected to increase. Second, fines are imposed if the prescribed mixing ratio is not reached. Third, there is a tax refund for a specific percentage of biofuels produced. South Korea's biodiesel industry began a pilot project of biodiesel in Seoul and the metropolitan area in 2002. It was produced with B20 at this time, and it was distributed with B5 at the beginning of 2006 when biodiesel began to be deployed in earnest. The reason for the introduction of B5 is that B20 has a problem with ongoing mobility in winter, which can cause problems with car engines. And if supplied through regular gas stations, the issue of illegal distribution has been raised. As the government's biodiesel distribution policy shifted to B5, production of the B20 decreased by a wider range than the previous pilot phase. Biodiesel uses 31% of domestic materials and 69% of imported materials as of 2012, and all domestic materials are used cooking oil. This part is environmental effect and problems. With increasing interest in biodiesel, the environmental impact of its use is on the rise. Among the effects are reduction of air pollutants and greenhouse gas emissions and deforestation. According to the EPA's Renewable Fuel Standards Program Regulatory Impact Analysis published in 2010, biodiesel from soybean oil emit 57% less greenhouse gases than petroleum diesel, and waste oil emit 86% less. This table describes the effect of improving the environment of air pollutants per unit of biodiesel. The higher the mix of biodiesel, the better the air pollutants, especially the PM particulate matter. However, plant resources, which were previously thought to be renewable, have caused various problems such as food problems and environmental pollution, and there has been a controversy over sustainability. Biodiesel's low-temperature properties are poor compared to diesel. When biodiesel is cooled below a certain point, some of the molecules aggregate and form crystals. As the fuel is cooled further, these crystals become larger, and it will gel and then solidify. The low-temperature characteristics of the fuel depend on the type and content of fatty acid methyl ester, which is a component of biodiesel. The more saturated fatty acids, the worse the low-temperature properties, and the more unsaturated fatty acids, the better. In addition to conventional diesel fuel tanks, a secondary fuel tank for biodiesel is used as a solution to address low-temperature characteristics. The secondary fuel tank is insulated and the heating coil using engine coolant is operated through the tank. Air There may be water due to materials acting as emulsifiers from incomplete reactions, remaining in the process, or due to storage tank condensation. The presence of water is a problem for the following reasons. Water reduces the heat of fuel combustion, causing smoke, harder starting, and reduced power. Water causes corrosion of fuel system components, pumps, fuel lines, etc. Microbes in the water cause the paper element filters in the system to rot and fail, causing failure of the fuel pump due to ingestion of large particles. Water freezes to form ice crystals to accelerate gelling of the fuel. Water causes pitting in pistons. Fuel is made of only non-edible vegetable oils and is said to grow well on marginal agricultural land. But by this advantage, the price of food would increase if farmers cultivate fuel crops to make more money. So if major grain producers such as the US invest in the biofuel market, the price of crops worldwide will soar. And if we remove forests from areas such as rainforests and open them up to land, there is a high possibility of global warming becoming worse. Meanwhile, biodiesel produced from seaweeds can create new agricultural land and get out of the problem.
가만히 서 있는 내가 너무 화가 나고 행복하지 마 절대로 행복하지 마 나를 떠나버리면서 don't you dare crack a smile 행복하지 마 절대로 행복하지 마 아무것도 변하지 않을 거란 거짓말 같은 말은 필요 없어 내가 너에게 제일 친한 친구란 말은 집어줘